Okay, so first question, what do you think of when you hear the word sustainability? A lot of people think about emissions, carbon reduction, innovation and technology, building products. What about supporting the Canadian economy? Sustainability needs to support and create local jobs, build resilient supply chains, and keep dollars within our community. Most people are very surprised to learn that when designed with intent, a mass timber building can compete head to head with steel and concrete construction. It's often unfamiliarity that equals uncertainty, or the fear of the unknown. But what's the cost of playing it safe? Mass timber is grown, harvested, manufactured, and installed entirely within Canada by Canadian workers for Canadian projects. And some stats about mass timber: it has a 70 to 76% lower carbon footprint than its equivalent in steel or concrete. Strategically using mass timber can reduce projects' overall carbon footprint by 10 to 20%. And as we know, trees, as they grow, sequester carbon through the growth cycle. And when this timber is harvested and manufactured into engineered products, they'll have incredibly long life cycles in buildings up to 100 plus years, as we can see in some of our heritage and old industrial buildings in downtown Winnipeg. And there's a significantly lower input energy into harvesting and fabrication for mass timber than there is with steel and concrete. But beyond reducing emissions and carbon footprint, sustainability needs to help make our economy sustainable too. And when you choose a mass timber product that's grown and made in Canada, you're also investing in the Canadian economy. What if your building envelope could reduce your heating loads by 20% or more, prevent premature building envelope or structural failure, reduce the opportunity for air contamination within an occupied space? Ice panels combine light gauge steel framing and expanded polystyrene insulation. There's no thermal bridging, no waste delivered to site, and the cold form steel within the panel is lightweight, has an incredibly long life cycle, and expanded polystyrene offers exceptional insulation performance values and a matching life cycle to the steel. Combined, these products equal lighter buildings, fewer materials used, lighter foundations, and a building that's going to perform as designed for many years to come, along with the potential for much better indoor air quality. You can think of ice panels a little bit like a thermos for your building. They lock in heat, resist moisture, and provide a lifetime of permanent insulation properties. Ice panels contribute to sustainable building, but it takes more than building products to bring a sustainable building together. Have you ever worked with a consultant who pushes for what they know versus being open to new ideas? It's easier for them. But sustainability demands creativity, technology, and continuous learning. It's incredible to have a team aligned with clients' priorities and have those priorities be sustainable ones at the same time. In a project we're working on, it's a Super 8 hotel up in Cross Lake First Nation, or Pimachikamak. Some of the questions we got from our design team during pre-construction were very pleasant surprises. The architects, for example, LM Architecture, they took an interest in learning about greenstone ice panels and the benefits that they could provide for the client. And they were already familiar with mass timber, so they were open to learning about new products. And the engineering team was asking questions about the environmental cost of shipping heavier products versus constructing with lighter materials on site. And creatively designed grid lines to work with multiple systems while we explored what system would serve the client's priorities best. Our mechanical engineers, so tower engineering on structural, mechanical, electrical, they're quite involved in searching for HVAC equipment that offered the fewest building envelope penetrations and came back with some suggestions for a heat pump system, HETAC, that only required 2 6-inch knockouts in the hotel suites instead of your standard PTAC, which is a much larger opening in the wall and that's a contributing factor to poor envelope performance and generally creates opportunities for things to go wrong with water infiltration and such. Our civil engineers were exploring solutions to minimize impact on sewer and water infrastructure, and we managed to remove a fire pump and a reservoir. Energy advisors providing multiple scenarios of data sets that helped the client shape decisions and added insulation to the building because it made sense. It would pay off, along with exploring other efficiency opportunities. Kitchen consultants, believe it or not, discussing delivery schedules for foods and dry goods, and by that process, reducing the overall building footprint. And landscape architects, of course, tried to plan the site to preserve nature and keep as many trees as possible, and inevitably they did not get to keep as many trees as they wanted to. But these were all thoughts that the team put into thinking about sustainability within this project. It takes an innovative team working together to think about sustainability at this level, but how do you bring it all together? And that's just a handful of the consultants. There's actually quite a few more on a project this size. The collaboration isn't just convenient, it's actually critical, especially in remote projects like Cross Lake. And that's where technology comes in, and it can impact your sustainability. Revit is building information modeling software, or BIM. Revit is used to build the building virtually first before it's physically constructed. Working in Revit allows collaboration between engineers, architects, and suppliers, like the timber company and the panels. Clash detection flags conflicts early, avoiding costly rework like colliding with structural components. Catching mistakes virtually means a shorter construction time frame, reducing total required construction energy, fewer wasted materials, and a lower project cost for the customer, checking off 3 sustainable boxes at once. Virtual collaboration also reduces travel to remote sites and allows for precision building modeling, which also reduces material waste by up to 15%. And that's because all the bits and components of the building, be it a timber, a column, a beam, or structural member, can be designed optimally based on the whole building versus over-designing those components for the just-in-case scenarios when each consultant works inside their own set of drawings or design. So the collaboration can have a big impact on sustainability overall. Imagine spending millions of dollars on a building and it didn't capture your values or your intended purpose, but instead reflected your design team's ideas. And this happens. In our Cross Lake Super 8 project, transparency, return on investment, and cultural respect were very important to the client. And these actually tie into sustainability. So with transparency, we're able to create an ethics accountability for the leadership within the community. And the owner gets to see the actual cost of everything, including any performance upgrades or added insulation or mechanical systems. A transparent tendering process also is a way to respect our clients' money and their reputation within the community. On the ROI, it's not just a hotel building. It needs to be a profitable business because poverty is still a big problem within these First Nation communities. So we can't build a hotel that doesn't cash flow and doesn't make sense. So we bring to the table our experience in hotel operations and provide insight into what makes a good hotel, along with data sets and design insights to their business performa to make sure we're setting them up to be successful for the future as well. And that results in good information and sustainable choices by the client and a working business plan. And the outcome is a hotel with 20% reduced utility bills, carbon deficit, and a design that reflects the identity of Cross Lake and Pimachikamak First Nation. Key takeaway is refuse to allow your contractors or consultants to create contracts that stifle creativity. They need to channel it. This isn't just a hotel, but a blueprint for the future. And that brings me to the big picture, how local action creates a global impact. Cross Lake Super 8 proved that innovation, local supply chains, and creative teams can deliver sustainable results at comparable costs. Sustainability isn't compromise, it's an upgrade. What can you do about sustainability in your projects? Bake local sourcing and innovation into your RFPs. Don't just ask for it, require it. Partner with firms who know your climate, community, and values. If they don't know about it, they need to be willing to learn and put in the time to learn about it. Challenge your team to innovate. Just because we've done it one way for 50 years doesn't mean that it's the right way today. In closing, sustainability isn't a buzzword, it's required for economic survival. Let's build a stronger economy together through sustainable building in Manitoba.
My presentation is a bit more on the, I guess, a bit on the broad strokes. Not much on data or specifics, although we can always talk about that in the comments after. I'm just showing the screen from my PDF editor here, and that's fine. So you can see the panels on the side. We can see the
Yeah, we can.
white
Yeah,
images. Okay,
yeah. As you say, you can
So-
see the panels on the side, but no biggie.
great. That's fine. So I'm a partner with Montane Architecture Works, and we have a sibling construction company, Bobsled Construction. Bobsled gets its name. Everyone always asks Bobsled gets its name because one of the founders was in fact an Olympic bobsledder in I believe the Calgary Olympics. So we believe, and it was kind of Bobsled was born out of an idea that founding partners of Montane Architecture Works had, that construction and should be more closely tied to the practice of architecture. So we believe strongly that our architect should be on site and talking to trades and talking to the guys on site and kind of helping resolve the details as a team. It allows us to, I think, push the boundaries a little bit more. And because I would say all of the work that we do with bobsled is not tendered. It's not, it's not put out to the public in a typical kind of design bid build process. It's usually construction management, and at times it's design build. In any case, it's always architect led design build. So there's a close tie to the client, and obviously um, a high importance put on quality design and sustainable kind of design. So the firm's been around for upwards of 30 years now. I'll talk primarily the focus of Montane Architecture work. Bobsled's been around for about a decade or so, kind of growing from small basement renos to larger kind of multifamily residential work. One of the early sustainable projects for the office was the Alloway Reception Center at Fort White that our founder Tom Montane had the pleasure to design and kind of work with the team at Fort White, who, as we all know, are kind of leading the way in terms of sustainable buildings and practice in Manitoba. This building was, I guess, the kind of the second major building at Fort White, and it was built. It's about 20 years ago now. So um, it's the building you enter when you come onto site, um, and has these really noteworthy kind of Tyndall stone, look like dry laid stone walls. So some of the interesting aspects of this building is use of a lake loop um, with a heat pump. So they're geothermal coming from the lake. At the time, it was very well insulated, very well um, detailed building that performs quite well. It's getting to the point where this kind of end of life of some of the systems and some of the timber is kind of wearing out, but it's still a beautiful building. Um, as we all know, construction industry is a major contributor to the um, to waste in this case, greenhouse gas and carbon emission as well. We're trying to think about ways we can improve that on a project to project basis. Embodied carbon will um, operational energy is obviously a large portion of the energy used in a building, and a fraction of the cost of a new build. So if we can focus our efforts on investment at the front end, both on design and quality construction, then it obviously pays back in the way of the building. Um, one of our one of my early projects with the firm was at with the Winnipeg Folk Festival, and it's not what you would typically think as a building or as a sustainable building. Um, the brief for this project, which is the backstage kitchen for the Winnipeg Folk Festival at Birds Hill, and it also functions as an off-season storage. The brief requested that the building um, would have the ability to grow, to shrink, to stay the same size, or to be removed from site completely. So in reality, that organization was um, basically used to and accustomed to working out of tents, and this was kind of their first foray into um, a permanent built structure on the festival site. Um, but there was, limitations to it. They were very aware, very concerned with the footprint on the site and being able to remove any trace, leave no trace. So for this, we were able to source I'm gonna jump ahead one slide. We were able to source a collection of industrial steel buildings that were uh, well, slated for demolition. As you can see here, this is probably from, I'm going to say 2009. This collection of buildings was being dismantled and set to go to the recycler or the salvage yard. We visited the site. Um, the construction manager, you see him kind of the center of the photo. I think it's the white frame. It was thought we maybe just be able to use one or two of these kind of buildings and call it a day. We quickly realized that they weren't appropriate for the design that we had. Um, but then after looking at it, we recognized that the span maybe could work, and with the benefit of a creative structural engineer, from engineering, we were able to look at possibly, rotating, reconfiguring, and um, reassembling a lot of these pre-engineered steel frames into a way that would work for the project. So this slide is just kind of a diagram of the reconfiguration. This was early on before we had um, figured out what was possible. Top left is the pre-engineered steel frames as they sat on the yard in North Kildonan, and the other frames are design explorations, let's say. And if we were to pop back up, this is the essentially the finished product. It's makeshift. It's barely a building. It's very ad hoc in a lot of ways, but it fits the personality of the folk fest to a T, and it serves them very well. It's not only a pre-engineered steel building; it's also the arrival point for performers and guests to the festival. There's this large uh, front porch that is just a welcoming spot for volunteers and performers alike. So it was well received, and it was a different take, I think, on scalable design and building reuse slash repurposing. Um, a lot of the work was done on site with site modifications to the steel. Um, very intensively used for short times in the year. And it was one of the first projects we've done with very large helical screw pallets. So, you know, often used in deck construction, small kind of ground anchors, um, just get either manually or with a bobcat kind of bored into the ground and serve as your supporting for a wood deck or what have you. We had this I guess, naive expectation that, the precision on a helical ground anchor would just be spot on for everything. But as you can see at the top of the helical ground anchor and the bottom of our column, things didn't always line up the way we wanted. So it was always, just a need to be flexible and work out details on site as you go. Another one of our actually, maybe a more common typology for our offices these days is um, uh, retrofit, deep energy retrofits of existing building. A common client we have is with um, housing co-ops. A lot of housing co-ops are kind of were built in the 70s or reaching a kind of a point in time where their envelopes need to be replaced. They're looking at renewing mortgages. They have some capital to reinvest. So we've been doing a number of housing co-ops, adding insulation, putting in better window systems, making more efficient with modern HRV systems. This project in particular is again with Fort White. This was the interpretive center, which is the building from the early '80s that a few years ago undertook a deep energy retrofit. At the time, we looked at different programs um, like LEED or zero carbon. We finally settled on green globes, just due to the flexibility of that program. There's some constraint with LEED that made it impractical. One of the primary ones was just the location of Fort White. I'm sure you're all familiar with these locations, and until now, it's probably up until like this weekend. I think there'll be transit access on the McGilvery side, but at this point, there is no ability to have um, efficient transit access, and that was a major hit on that side. Um, but we introduced um, about an extra foot of insulation on this building, improved the energy efficiency by I think their energy or their heating costs are down about 70% from what they previously were. New windows, replacing cladding again. It's a beautiful building. The original building is beautiful. Have beautiful wood cedar shake roofing and siding. Um, we tried to do it justice with a new kind of metallic skin that we feel is quite successful, but I know there's always various opinions out there. But we wanted to clad it in honor with something that had a scale and texture that was reflecting the original architect's vision. Um, and Fort White, as we all probably know, is the new building opening up on McGilvery. We're heavily involved with the formation of that vision um, at the time. So a lot of the moves, a lot of the programming elements were we had helped the organization flesh out, and we're really proud of those efforts as well. There's just a couple of um, image shots of what happens. So if you're not familiar, a lot of times in architectural offices will assist entities, companies with kind of visioning the future of what they could be. They're looking for aid in programming or fundraising and those sorts of things. So you start to develop ideas, and you often throw a lot of different things at the board and create um, captivating images. I think so there's a few things that were developed in Fort White, and again, the nature of that site it's kind of it's about reuse, and it's about um, some industrial waste, like it'd be a former cement cement yard. Um, we got into items like thinking about it as a possible building and what those systems could be and how they could be implemented. And that was kind of our first foray into um, passive house design and construction. Um, we from Buffalo Crossing to today, we've been involved in a number of passive house design. We currently have two single family passive homes in construction, both being built by bobsled, as you mentioned previously, and we have a larger um, multi-family building in the design phase. So I'll just kind of breeze through these a little bit. Um, Basic principle. One of the things that we found in our climate, I mean, designing and constructing a passive house building isn't easy. I think there's a lot of principles that we're now employing on everything we do. But to reach a point where certification is realistic, it takes a lot of rigor, and it's a large commitment. Um, you find that because we're working hand in hand with the builder on these projects, the detailing and the air sealing isn't necessarily our greatest challenge. I think the greatest challenge comes earlier on in the design phase and working with the client to really determine um, the coordination and the um, the layout of rooms, and just having all of that known to be able to distill it an efficient form. And but as an architect, we're also interested not only in the performance of the building, but the effect that it has, the comfort, and really a big part um, of successful building, ensuring that a building will last and be cared for, and that it's loved by its users, its occupants. So a lot of care is taken to give the owners and the community a building that will be kind of embraced. This project is a single family home on Cedar Place in Norwood Flats, just off Lindale Drive. You can see the Red River on the left of the screen, and Lindale Drive is kind of in the center. The reddish square is a single family house that is currently under construction, and will be done later this summer. Our process, we're talking about, getting it right. We tend to spend a lot of effort on schematic design, and often that involves study models, different sizes, scale, material, just to be able to explore different notions of what the project could be. Some of you may recognize this from Design PH. It's a modeling tool to help realize these particular projects. And the layout in this case is a simple family home, but the one thing that stands out in these images is that the thickness of the exterior wall. It's that way thick, and it's about 20, well, it's almost 2 feet thick. There's a 2x6 structural wall, and then a non-structural engineered wood truss on the outside of that. That's about 20 inches deep and is filled with cellulose insulation.
If you just want to wrap up so we can move to questions.
Oh yeah, for sure. Yeah, and I'll leave it at this project. So again, the section. This house is built without a basement, which is kind of it, in some ways it's an interesting aspect of it. We have a 3-foot deep floor joist that again is full with cellulose, and a 3-foot deep roof joist again with cellulose. It's one of the schematic drawings. A rudimentary rendering of the house and house in construction. We talked about mass timber a little bit. This house is the floor structure is NLT, nail laminated timber. We've been pouring that on some of our multifamily work, as well as a way of reducing the amount of drywall. For one, two, it reduces the floor thickness, so allows us to keep our building height and volume down a little bit, and depending on the situation, it's an appropriate ceiling finish as well. So we're happy with that approach. In some instances it's not appropriate everywhere, but it can be quite effective. Another house that is under construction, that was in Wolseley. Noteworthy about this is just the site configuration and all of the factors on the site, leading to what would otherwise be a very odd form. And the shape and the massing of the house wouldn't be found on any other site. But the combination of dealing with the river, trying to capture views, trying to be a good neighbor to the existing kind of building fabric around, trying to orient the building in a manner which captures enough solar gain, and again capturing views out, and respecting kind of the stability of the riverbank, all played an impact to the form of this particular project. And so it was a challenge in a lot of ways. An old plan, some other images of it, and then this plan is just we find sometimes non-orthogonal plans, and it's not because we want to do that. It's often just there are all the other factors of yards, streets, and those sorts of things that kind of lead that way, and orientation for solar and passive plays into that as well. But I'll leave it at that.
All right, great. So we're going to move on to questions. So we've got a few in the chat here. So Fletcher, if you just want to stop sharing your screen, that'd be
Yeah,
excellent.
yeah, I'll find it.
All right. So for starters, for Rod, did you do overall life costing for your project in addition to looking at mass timber? In particular, I'm curious about the insulation. What are the embodied carbon implications of EPS? Were alternatives considered?
Yeah, great question. We often consider life cycle cost. We also include rebates from Manitoba Hydro and operational maintenance costs. We also take into consideration as a contractor, we might finish a project, but the project's never finished, and that there's warranty calls and things that come down the road in line along with building performance. And if it's not right, it ends up being our problem. We have those scenarios that happen. So, so we look at insulation properties, specifically expanded polystyrene being 98% entrapped air, very efficient use of hydrocarbons, and very effective at dealing with extremely harsh environments, especially in a northern climate where open cell insulation products like fiberglass or some of these other options tend not to fare well. And don't provide the same performance. And then as compared to some of the other alternates like urethane foams or polyisos, with the expanded polystyrene, it's just atmospheric air within the closed cell. So, we don't have inflated R values going into the building. We have a long-term performance, a 50-year LTR on that insulation. It has the ability to dry if there's any vapor drive or humidity driving into it. So it can actually dry and retain its performance for more than 50 years is what the data shows. So it's we and this bridges into the next question, right materials, right places. It's very important to utilize the right materials for the right job. It's not the solution all the time, but in this particular project, it worked out to be the correct solution.
All right. So, interesting comparison between wood and concrete. Considering the significant processing required to create engineered mass timber products, how does the energy consumption and associated emissions compare to advancements in lower carbon concrete mixes? Example, with supplementary cementitious materials, carbon capture, utilization, and storage. Have you seen the full life cycle assessment that accounts for these evolving concrete technologies?
So, great question. The answer is I don't actually have that data in front of me. We do, again, right material, right places. And it's not that there's no concrete or steel within the project. There certainly is. And strategically, we have a concrete foundation and steel underneath the floors where we have high moisture environments and just heavy loads coming down within the building. And so it's not that the whole thing's mass timber or the whole thing's an ice panel, but it's the strategically using um, the right material in the propagation. So while we're considering the client's cultural values, the aesthetic that they want in their design, and the performance and sustainability, mass timber above the deck makes sense. Concrete and steel in this project makes sense below grade, and so that's generally tends to be the process in some of that decision making uh, when materials are being selected by, and it's usually the client's choice. So we get excited when they choose sustainability in their material selections. It's not our decision; it's what they want for their project.
Yes, and we'll be talking more about materials in a moment. So let's see if we can get one last question in before we take a short break. But how are materials compared to measure embodied carbon impacts? Did every product have a valid environmental product declaration? How is GWP, global warming potential, measured and balanced against the thermal energy efficiency properties of the product?
Yeah, it's another great question. So some materials like the mass timber would carry an FSC certification with it. So it has a chain of custody. And sometimes those certifications carry some significance and sometimes they don't make sense. Like we've actually seen those certifications where resources are harvested in Canada, then shipped to another country like overseas where they're manufactured and then shipped back. But they carry that certification because the facilities carry that designation or certification. Doesn't necessarily mean that that's the most sustainable use of that product because it carries a designation. You know, we like to think about the shortest trip and the least amount of handling of a material. So if it's sourced in Canada, then it moves to a fabrication facility that's closer to the job and then gets delivered to the job and installed. No matter what you do, that's going to still have a lower carbon footprint than shipping that overseas and back again. And sometimes those certifications, unfortunately, carry a little bit of greenwashing with them. And so we have to apply some practical sense when we're thinking about and deciding what's the best product or material for the job.